Hi guys. Okay, so this video we are going to look at alkanes. Now I have this entire, plan to cover, but I'm not sure with the time constraints if I will be able to finish all of this and make the video small and reasonable. But if not, then this is going to be carried over to the next video. Okay, so just keep it as continuous. Okay, so but we plan to discuss all these things. So first is introduction to alkanes. What is that? So first is the introduction. So alkanes, those group of molecules that are carbon-carbon, and they have like carbon-carbon hydrocarbons, basically, they have single bonds. So they are also considered to be saturated. So the entire molecule, carbon-carbon, carbon hydrogens, and everything else they will have they are all single bonded, okay? No double bond. So that means they are saturated, okay? The double bonds and triple bonds creates unsaturation. So these are also called as saturated molecules. Next is the naming. So the IUPAC naming for these, the IUPAC, I-U-P-A-C, the IUPAC naming is based on this like formula, which is C, number of hydrogens. Let me look at another color. C, carbon, some number of carbon, whatever the number of carbon atoms is, the hydrogens is going to be double of that. So CN, H2N plus 2 more. Okay, so whenever we are doing the nomenclature, right, in the nomenclature in organic molecules, we will have the suffix and the prefix. Suffix is the ending. Suffix comes in the end. So suffix relates to the end in the molecule, in the name, and prefix is in the beginning. Okay, so the name is going to begin with something and it's going to end with something. So what is that? It depends on the number of carbon atoms. So for alkanes, as the name says, ane, right? So ane. So this is going to end in A-N-E, alkane. So their ending is the same, ane, like methane, ethane, propane, butane, those things, okay? But beginnings are different, and that beginning depends on the carbon atoms. So let's look at this. So one carbon atom, so let's do this. If there is a one carbon atom, so these are the saturated hydrocarbons, but one carbon atom, the name, the prefix is going to be meth, M-E-T-H. And then the ending is, whatever, ane. So these are all prefixes here we are discussing. Okay, and these are the number of carbon atoms in the molecule. Okay, so if there are two carbons, then the name is eth, E-T-H, eth. If there are three carbons, then it's prop, okay, P-R-O-P. Then if there are four carbons, then it becomes but, B-U-T, right? And then butane, like that. 5 carbon atoms, the name is pent, P-E-N-T, right? 6 carbon atoms, hex, H-E-X. 7 carbon atoms, hept, H-E-P-T, right? 8 carbon atoms, so let's come here. 8 carbon atoms is oct. 8 carbon atoms, the name is the prefix. It's going to start with oct. 9 carbon atoms, the name starts with non, N-O-N. Sorry. N, nonene, like non, okay? And then 10 carbon atoms is dec, D-E-C, and so forth. Okay, so the prefix, all of them, sorry, capital, capital, capital. Prefix is coming in the middle, in the front, so capital letters. Okay, so that's one piece about the naming. Next is, let's do a few examples and then you will get it. Okay. So what we are doing here is number 2. So based on this, expanded, condensed, and line structures. Let's do that. Okay, so we will have the molecular formula. And we already covered this in the previous video, but this is just a little practice here. So we have the molecular formula, then we are going to do the condensed, right? Condensed formula. All of them are formulas, basically. And then comes the structural. So condensed, and then comes the structural formula. And then comes the line diagram. And then, of course, the name, right? Okay. Let's look at this thing here. So we have here, let's look at a different color. Okay, so let's say we are given this one example, and that is of nonane. Okay, nonane. So someone says, okay, this is the name, nonane. Write down the molecular formula of that one first. Non stands for, non alone stands for there are 9 carbons. And ane stands for that they're all single bonded. Okay, so single bonded. So what that means, the carbon and carbon hydrogen will be a single bond, right? So nonane, that means 9 carbons. So using the CnH2n plus 2 terminology, what can you get? You can get, let me do this here. It won't fit in because there are 9 carbons. So we will do this here. So here we will see, so single bonded. So CnH2n plus 2. Okay, so here we will see that if there are 9 carbons, then hydrogen is 9 times 2, right? Or 2 times 9, and then plus 2. So let's do this here. 2 times 9 and plus 2. So this makes it CnH18, right? Plus 2 is 20. So this is the molecular formula. All right, so that makes it the, let me put this here. This is the molecular formula. All right, that's one piece. So next is, how are you going to create a condensed formula? So that's one piece. Next is the condensed formula. Condensed, or rather, and then all these condensed and structural, all of them can go same, condensed. All right, so first thing always is that you should first create the chain of carbon. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we make these 8 carbon atoms. Then we are 9 carbon atoms, and then so that we have the cage. The next is fill it up with hydrogens. So first always make the cage, right? And then fill it up with hydrogen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay, so fill up this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay, so this is actually, in reality, this is actually, we're trying to make the condensed formula, but it comes out of the structural formula. Okay, so they go hand in hand. So this is also the structural formula. Okay, now here you're going to see a few things. these carbons, the CH2s, 1, 2, 3, 4, 5, 6, 7. Okay, so these seven carbons, you will have to put them as like dots also, right? These can be put as dots, but let's put this molecule here. So CH3, the corner ones, CH3 is here. Okay, and then come as CH2, all seven of them. 1, 2, 3, 4, 5, 6, 7. Did we get this? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, and 9. I don't have the space. You see, like, because of all these limitations of the space and like these molecules, and carbon can make, so this is, so you don't have to show this here. Actually, this can be put as CH3. Okay, I just wanted to bring this CH3. So this is CH3, and here also is CH3. So all the nine of them. Okay, now just for the sake, to show you the connectivity, I have put the, the line in between the carbon-carbon. You don't have to do that. Another way you could do is CH3 brackets CH2, and there are 7 of them, and then comes CH3. And this can also further be written as CH3, CH2, 7, CH3. Okay, that's how you will see them. Okay, so this long chain can be condensed into these, these forms, these formulas also. Now we are going to write these. So condensed and the structural, in order to get to a condensed formula, you need the structural formula. And in order to make the line, you need the structural formula also. So structural formula is very important. So now let's look at the line diagram. So all the ones that I labeled red, right? Those ones, those carbons, you can just show them like, let me get another lighter color for red here. So 1, 2, 3, 4, 5, 6, 7, and then the outer ones are these ones, this one and this one. So this is outer and the methyl outer, and now you just connect them. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's the line diagram. Okay, so this is going to be, this is basically the test question also. So you will be given some, so you should know, so the naming also, this is the ending. These guys are the names of these, the end ones are the methyl, METHYL, methyl group. Okay, the side groups, the side chains. Okay, now we are going to look at the next piece, which from here is the substituents in alkanes. Okay, sometimes the way they give in the book, it's not a very like it doesn't follow a pattern, a linear pattern. So I'm going to give you this, substituent. Organic chemistry can be very like scattered. All right, so let's look at the next piece. Right here is the substituents. Oh, okay. Oh, sorry, wait a minute. All right, next. Okay, substituents. In alkanes. Okay, in alkanes. Now here you will see, you can put fluorine, chlorine, bromine, or any other functional groups, right? That we talked about in the previous video. So you can put any of the functional groups. You can put OH, you can put NH2, you can put an oxygen, you can put, you know, anything. And then the names change, okay? Besides that, even here, you can put another like CH3 group, another, you know, propyl group or methyl or phenyl group also, you know, so those things can be put on these. So how do their names change? So here's the thing. We are going to discuss here the alkyl groups. Alkyl groups are coming from the alkanes. So what if there is more, like some kind of branches? Remember, carbon can form branches also. In a straight chain, carbon can form different branches. So how does the name change? So here is the thing, alkyl. Alkyl is like, for example, let's see here, C, if there is a CH3. Now, CH3 and R is rest of the molecule. Okay, rest of the molecule, we don't care. So the name is, in that case, let's put this here, the name, what does this become with just the CH3? Okay, and how it is shown, the, you know, the line diagrams. Okay, so here we see the CH3 with R. So this, it becomes methyl group. Okay, if there is this long chain and there is one methyl group ending, so in other words, one CH3 on somewhere on the side or in the middle, then the name will be methyl. And then whatever else is there, you know, like the big chain, like heptane or whatever. So that's thing. And how would you show this? Just one and then R. That's it. Okay. Now, then next is the CH3 and then CH2 and then R, rest of the molecule. So this is the ethyl, ETHY, ethyl, and then whatever. So 1, 2. Remember those 2 carbons and then R. This is how you will show. Next comes the propyl. So CH3, CH2, CH2. Okay, and then R. So this is the propyl, 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 and then 1, 2, and 3 carbons, and then R, right? And then now, if there is another variation here, CH3, right? And then you have another carbon here, and then you have another CH3, right? And this carbon has hydrogen, and then it's connected to R. So more like a branch, right? So this becomes isopropyl group. So these are all alkyl substituents, basically. Okay, alkyl substituent, isopropyl, PYL. Okay, isopropyl. So in a line, you will see it like this. So one carbon, another carbon, a third carbon here, and then the R group. Okay, like a Y. All right. Next is the butyl. So CH3, CH2, 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 and R. Okay, so CH3, CH2, CH2, sorry, not CH2, sorry, this would be, yeah, maybe CH3, yeah, CH2, and then R. So this becomes butyl, BUTYL. And how will you show this? 1, 2, 3, 4, and R. Okay, next comes the isobutyl. Now, isobutyl is branched. So here is a CH3. Here is one carbon. Here is CH3, right? And then you have carbon and hydrogen, and then you have CH2, and then you have R. Okay, so this is isobutyl. Isobutyl, BUTYL, right? And this BUTYL, how will you show this? This is one carbon, another one, another carbon, and you have the CH2 and then R. Okay, so this is that CH. Okay, so like that. Now, so isobutyl looks like that. Then there is a very interesting secondary butyl also. Secondary butyl is CH3, right? And then you have CH, and then you have CH2 and CH3, like ethyl group, right? And the R is over here at the CH. So what does it look like? This looks like here, carbon, this is R here, and then CH2 and CH3, right? So once methyl, methyl, CH, CH2, CH3. So this is how it looks. And this is called secondary, SEC, secondary butyl, BUTYL, okay, butyl. And then there's another one called a tertiary. So here you have CH3, CH, right? And then CH3. Oh, sorry, not CH. Put it here better. Okay, here is C, CH3, CH3, and R. So this looks like here, 1, 2, 3, and R. So this is tert or tertiary butyl, tert butyl. So one is a secondary butyl, the other is the tert butyl, okay? Besides that, we also have, like for fluorine, if we have the name fluorine, if fluorine is attached, this becomes fluoro, right? If chlorine is attached, the name becomes chloro. If bromine is attached, the name becomes bromo. And if iodine is attached, it becomes iodo. Okay. All right. Then we are going to give the nomenclature. We are all preparing you for the nomenclature. So we will discuss the nomenclature. But there are other types of substitutions also, the primary, secondary, and the tertiary amines. So here is, the carbons, right? So let's look at that part also. So here is the fourth part. Actually, yeah, fourth. Okay, here is a on carbon, substitution on carbon, other type of substitution on carbon. Actually, it's a part of this only. So I'm going to erase this. Excuse me. So here, so if there is only one R group and 3 hydrogens attached, so this is called the primary carbon, and primary carbon is 1 degree. So this is primary carbon, and this primary carbon has a primary carbon has one other carbon attached, actually. But so primary carbon, so this main carbon with 3 hydrogens attached or bonded with, attached to another carbon, okay, another carbon. And then comes the other one, the other pieces, if there are 2 R groups, R dash, okay, and then there is another R group, okay. Now these two are 2 carbons here, like R stands for carbon. So R and R, and then there is 1 hydrogen. How do I show this? 1 second. We have to show it is not the best, but R, carbon, R, and then here is the hydrogen, and this is the hydrogen. So this is the second degree. This is the second degree. So this is secondary carbon. In other words, so this is called a secondary carbon, because here carbon has 2 other carbons. So this secondary carbon means that this carbon is attached. See, instead of attached, let's do bonded. That's better term. Bonded to another carbon. Carbon bonded to one carbon, of R group, whatever that R group is. All right. Sorry about that. Okay. All right. Next is when the secondary carbon, when does the carbon become secondary? When it's bonded to 2 carbons of some R is some other structure. Okay. Next is the tertiary. tertiary is R. Remember, R contains carbons also. It's some kind of a group or some other part of the molecule. And it can be the same, it can be different. So if it is bonded to, so this becomes a tertiary carbon, or a tertiary carbon is Tertiary, tertiary carbon. And this is when it's bonded to, when the carbon is bonded to 3 carbons of some other part, R, okay? And then there's a quaternary carbon also, when all of them are different groups attached to carbons, okay? So here you have the quaternary carbon, QUARTERNARY, quaternary carbon. So this one is bonded to 4 carbons of some other structure that is also having carbon, okay? So that was the substituents in alkanes. Now, next is we are going to look at the cycloalkanes. Before that, I want to do the common abbreviations, you know, so it's just easy. So let's do the common abbreviations, and then we will look at the 4, yeah, 4, because it's just common abbreviations. So here are the some common abbreviations in organic chemistry. So what are those? So they stand for R. R stands for rest of the molecule, okay? Rest of the molecule. Next is, if you see R dash, you see R double dash, you see R triple dash, you know, and like I said, these could be, these R's we talked here, these R's could be different groups also, different, you know, structures. So anyway, so what does this mean? This means this sign, or the double or the triple, this means prime, R prime. Okay, we call it R prime. Okay, it stands for prime for different R groups, for different structures, you know, rest of the molecules, different R groups. Okay, next is X. What is the meaning of X? X stands for halogens. Okay, halogens, and these halogens are fluorine, chlorine, bromine, iodine. All right, next is, you will also see Y or Z. What do these stand for? These can stand for oxygen or sulfur, right? Or maybe even phosphorus, depends, you know, which one. If you see M stands for metal. Okay, so these are the short forms. Now, if you have AR stands for aromatic. So that also is a group, aromatic, okay? And if you have pH, this is phenyl. So we will discuss this, you know, when we discuss the phenyl, the R groups, but that's the thing, right? Now, we talked about the substitutions, which, you know, meth, eth. So this would be like methyl, ethyl, but generally it's meth, eth, prop, isobutyl, isopropyl, you know, those things. So those are also there. Like tert-butyl is called T-butyl, like that. All right. Now, next piece is the what is the next one? Cycloalkanes. Okay, and then their naming. Okay, cycloalkanes. Now, let's look at the cycloalkanes. Now, we had been talking about the straight chains and a little bit of branching we discussed, but not too much. But here we are going to look at a very interesting part, which is the cycloalkanes. The cycloalkanes are the like the ring systems of alkanes. Okay, now here cycloalkane, how do we show them? So if you have like C3H6, okay, C3H6. So the formula for the cyclohexanes is CnH2n. So that is why C3H6. So this means CH2, CH2, and CH2. And these are bonded. Okay, so that's how that makes the 6 hydrogens and 3 carbons. So the line diagram is this. Okay, the name is Cyclo. And because there are 3 carbons, propane. Okay, so that's the nomenclature. Next, if you have, now let's say we are giving you draw or cyclobutane. The structural formula, line formula, molecular formula, and the name is given. So what does that mean? Cyclobutane obviously means cyclic system. Butane, butane means it's coming 4 carbons. So CnH2n, that means but, 4 carbon, ane, they are all single bonded. Carbon-carbon will be single bond. And cyclo means it's a cyclic system, right? Cyclic system, or it's a ring system rather. Cyclic means rings. So this will be rings. So in the ring, a ring of 4 carbon atoms, each single bonded. Formula is this. So this becomes what? This is C4 and H, C4H, 2 times 4. So this becomes C4H8. Okay, so what will you do next? So let me put this one in a different color, just so there is a C3H6. C3H6. Okay, so in this case, what are we doing now? We are going to place CH2, and it's a ring, so CH2. So we have to form a ring, CH2 and CH2. So single bond, there's a single bond. It's the ane, it's not ene, it's the ane. So they are all connected. So this looks like this, cyclobutane. Okay. Next is they have given you a name of, let's say, draw a molecule of cyclopentane. So cyclopentane, Pentane. Okay, cyclopentane. Now cyclo, as I said, this is the cyclopentane. Pent means 5 carbons. Ane means single, double, single bond. And cyclo means it's a ring. Okay, so what will you do here? You are going to have C5H2 times 5, and this becomes C5H10. Okay, so C5H10 means CH2, and you have to draw it in a ring now. So CH2, 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 and CH2. 1, 2, 3, 4, and 5. Okay, not the best, but this is the way this is shown. Okay, so ideally it is actually C, 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 and C. Okay, and here H, 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 and hydrogen. All right. So this is the way, you know, it looks better. This is better. Okay, this one is. So this is the way, this is the cyclopentane looks like. And same thing, I'm going to fix this also. This also is just to show you, but actually it should be done like this. Carbon and carbon single bond, and single bond, and the rest has to be at an angle here. Okay. Hydrogen and hydrogen, hydrogen and hydrogen. All right. So this is how it will look. Okay. Next is the cyclopentane, cyclohexane, and all those things. Okay. Now, so you get an idea. All right. Now we have this one example, second example, third example, and so forth. Okay. Now let's look at the naming in this case. That will be just a little bit easier here. Naming of the naming the cycloalkanes with substituents. Okay. Naming cycloalkanes with substituents. All right. So here, what do you see? Number one, let's say you are given something like this. Okay. So now you understand that this is pentane, right? This is the pentane. And five carbons, right? And there is only one methyl group. So we will call it the methyl cyclopentane. So methyl cyclopentane. Okay. Let's say you have another thing. So this is just one. Let's name this here. Sorry. Five, six. And actually, we're just going to stop here naming the cycloalkanes. All right, we covered a lot in this group. In this, naming the substitution. So yeah, so the naming the cycloalkanes, we are done. Cycloalkanes and naming. Common abbreviations, substitution patterns for carbon, we have done. So this part, the naming of the alkanes, and then the reactions of the alkanes, we will cover in the next video. All right, so let's finish this up here. Let's say you have another example of let's say two of them, 1, 2. Okay, cyclopentane, but one side is here. So one side is one methyl and the other side. So how do you name them? So you always start from the side which, gives you the lowest substitution. You like the substitution, like you can go in this case, you can go this way, but you can go this way, right? Or you can start the other way also. But which way will you go? You will go this on this is preferred. This one is preferred. This is preferred. Why? Because it gives you the lowest substitution, the lowest number of carbon. So preferred, and I'll show you what that means. Okay, here is this thing one more time, and this is one. Now, when you will have to label name you have to number them. So lowest number of carbon. So this is of course the methyl group. Don't start from here. Methyl. This is the methyl groups. 2 methyl groups attached to 1 carbon. Then if you go here, 2nd carbon, and then the 3rd carbon. So 1, 2, 3. You reach the 3rd methyl, the 2nd methyl group at carbon 3. So C1. So C1 and C3 are the lowest. But if you do it the other way around, let's see, then the other methyl is further away. So here you see, so this one, this. But you go 1, 2, 3, 4, 5, right? Here 1, 2, 3, 4, and 5. You see that? Here this is C1 and C4. So we prefer this one. This is preferred. This numbering is preferred because the carbon, the methyls are coming at a lowest number carbons. So what are the names now? How do you name them? The name is 1, 3, right? 1, 3. The numbers come first, then comes a hyphen, then there are 2 methyls. So this becomes dimethyl, methyl, and because the parent is the pentane, so the name pentane. So this is the naming. So introduction to naming. So pentane is the parent, right? This is the parent. Dimethyl are the substituents, and there are 2 substituents. And this is the 1 and 3 are the carbons, the lowest carbon, lowest numbers on carbon, 1 and 3. Okay, and you can start where 3 is, you can put that as 1, but you have to look at the rule is that the the substitution should come at the lowest carbon, numbered carbon. So that's how you name. Okay, let's look at another one. And again, this is again a small introduction to your naming also. So let's look at this one. Here you have 1, 2, 3, 4, 5, 6. Okay, that is 6 carbon atoms. Okay, 6 carbon atoms, hexane. Because it's a ring system, so it's a cyclohexane. So 6 carbon atoms, ring system. So you just have to put cyclo, right? And then it's a hexane, so hexane. And that name is from the alkanes. And so again, we have this here, this piece ane means all of them are single bonded, saturated system. So cyclic is the rings, right? So the ring system. And there are all hexane means, hex means 6 carbons. Okay. Now, here in this case, we have the scenario, and in this, we have 1 chlorine here. Sorry, 1 chlorine here. There's a chlorine here, and there is a methyl here. Okay, methyl. Now, methyl is just shown as like a line, right? So we know that this is the methyl group, right? Methyl group, the methyl. Now, where will you start? From where? Should you start with chlorine or should you start with methyl? So that's the question. So we always give priority to the halogens. So here, write down a note, halogens have a priority over the alkyl substituents. Okay, so here halogens could be, fluorine, chlorine, bromine, and iodine. Okay, and alkyl substituents are like methyl, right? Alkyl, and so forth. Propyl, butyl, isobutyl, those things. Okay, so here we will see that in this case, so we are going to name. So let me just put this here. So again, you can go this way, start with chlorine side and go this way, or you can go this way. So you always look at the shortest route, the shortest numbering system. Okay, so always we look at the shortest numbering. On, or shortest or lowest numbering on substituted carbons, on carbons, with substitution. All right, so what is the name here now? So this becomes, one more time, draw it, methyl chlorine. So here we will have 1, 2, 3. Remember, these are the carbons. These guys are the carbons. So 3, 4, 5, and 6. So here we have 1 hyphen. So again, in the naming, we put the hyphen. Okay, this is another piece between the numbers and the name. Hyphen, H-Y-P-H-E-N. Okay, so, and only the first letter is capitalized. The rest, all of them is one word. The rest is all one word. One word. Because it's a name, so this is the only thing that gets a capital. So the rest is all one word, lowercase. And so that's the naming. Okay, here, so we will cover all the rules in the next video, but just to an introduction here. So here, 1 hyphen chloro, sorry. I think chloro is capital or not. Chloro dash 3 dash methyl. Okay, these are the substituents. So methyl. And then comes the cyclo. This is the parent, cyclohexane. Okay, so the cyclohexane is the parent, the ring system. That's the parent. And so this parent gets the capital here, capital. And this is lowercase. And this one also is lowercase. We put hyphen, right, to show between the number and the words. So hyphen is wherever the carbon is, right, carbon atom. And chloro for chlorine, methyl. Now chloro is like I already said, that it gets a priority over the methyl. Okay, and cyclohexane. So everything, so a lot of things. Hexane, as we said, this piece right here, it's all going to show a single bond. This is the single bond. Carbon-carbon single bond. Hexane. Hex stands for 6 carbons. Cyclo is the ring system. So many things. And methyl is the CH3. Chloro is the Cl. All right. So this is how we will name them. So in the next video, we are going to cover the nomenclature and the what is it called? The nomenclature and as well as the different reactions. All right. Thank you for watching. Bye-bye.